The historic Bessemer iron ore mine, located in Bancroft, Ontario, Canada, was open-pit mined 100 years ago for over a decade.
Massive magnetite occurrences are found right on the surface. These two pits that have been mined definitely have magnetite occurrences right on the side. Stockpile was mined towards the end of I guess 1917 or so, and then because of the fact that the demand was falling off, they just simply had about 50 or so thousand tons left right on the surface, and it's mostly massive magnetite. As a result of the exploration work that we have done so far at Bessemer number 3, we got good continuity from the 00 line all the way to 350. We know the mineralization is there, and in fact we intersected a true width of about 55 meters, averaging 49% weighted average magnetite content. That means you're going to have lots of massive stuff and probably some which is below 40%. So the average comes out to be that way. In terms of the actual size, I would say minimum 4 to 5 million tons. The grade that we're getting over here and the grade that has been reported from Bessemer number 4 is literally the same. It's also probably doing some plunging, and here it might be rising again because we know the magnetic signature is quite high. The more I looked upon it, I decided that there's no question about it. This is really a skarn zone, which is a reaction between magma coming into a certain environment where it reacts with the calcareous rocks and produces the so-called skarn zone. And in the process of reaction, it produces these massive magnetites. Skarns have a tendency to produce high-grade mineralization. For example, the Kiruna deposit in Sweden at one time was considered to be an iron formation type of deposit, but now they're thinking that it's actually a skarn zone. And it's a huge deposit. It's a huge deposit.
The Kiruna deposit is about 4 kilometers in length and 80 meters thick. In over 100 years of mining, only 1/3 of this skarn has been extracted.
There is great continuity to this horizon. It goes from number 1, number 2, number 3, and the main Bessemer deposit over here, which is at least 2-3 kilometers in length. And all of it is popping up to the surface, so therefore we know that it's probably one on the same horizon. There is more skarns further up north, where we have the Rankin deposit and the Childs, and a huge deposit slightly further to the northeast called Stevens.
Previous drill results at both Childs and Rankin have proven 10 million tons each. The Stevens deposit alone is expected to have over 500 million tons of iron ore at a grade of 35%. Royal Crown will further investigate the largest magnetite zones with additional diamond drilling. An additional byproduct of the skarn is January's birthstone, garnet. Aside from jewelry, garnets also have numerous industrial uses.
Garnet has been mined in the past specifically just for garnet. So this could be an interesting byproduct. Here we have a situation where we have almost 100% garnet in some sections of the skarn zone. So the profit from that can be quite impressive. In terms of environmental damage, this would not be much of a damage at all, because it would be essentially an open pit. And if we, let's say, finish mining it, okay, all you have to do is flood it, put a few trout in there, and then first thing you know, it's going to be a super fishing spot. Iron properties in this area are one of the most common places, in Canada. First of all, it's in a terrain which has been a former mining type of environment, so the infrastructure, it's all here. In terms of the market, all we have to do is ship this material to the Hamilton area here, and it can be ready for steel production within a very short time. Hamilton is close by to Toronto, and Toronto is a handy port area which can be used for shipping the ore globally then.